Hello, hello, hello. Welcome to another episode of Xa Talk Show. Hello, hello, hello. Today we are going to code Wolfram Language. Fantastic. Advent of Code. 2023, day 12. Hello guys. So this is Glove 80 keyboard. Fantastic. Ultimate Hacking keyboard. Fantastic. Nulia trackball. Fantastic. Logitech 502, I think. Fantastic. And this is Svalbard, Svalboard. Superb. I'm gonna use it, but not yet. Okay. You search on my website, search for Xali keyboard blog. You'll see reviews of all of them and video reviews. Okay. And now let's just code. Advent of code. Wolfram language. Concentrate. We need to concentrate. Advent code day 12. Okay, I haven't read the problem yet, so let's get prepared. Do we have everything? If you are here, say hi. If you are watching offline, feel free to skip around. And let me introduce you Wolfram language. Okay, now you can get it free. Just search for XR Wolfram language tutorial, Wolfram script download. There is where you download it. Okay, let's copy it, close it. Reopen it, copy the path, and on the pink window is all my command calls and keyboard strokes. As you see, I work on my website. You can see all the command names on the right side and keystrokes on the left side. I'm using a Vora keyboard layout, and I'm using Xafly keys. Xafly keys. Search it, you'll find it. The most efficient key binding system for Emacs if you are using Emacs, and Emacs is the most powerful text editor. If you are a programmer, you won't go wrong. It's a long-term investment for 10 years for your profession, for your livelihood. If you are a programmer or if you are anything technical, dealing with computers. So if you are watching here, say hi. Hello, Damsek. Hello, Dan. Hello. Yes, thank you. Hello, Damsek. Just started using Xafly keys. Fantastic. Okay. So let's begin Wolfram language code. Okay, Wolfram language tutorial. You can learn the whole language, download it and free, and use the whole learn the whole language from the ground up. So there's no if you know one programming language such as Python, JavaScript, or even C, C++, Java, then this is good for you, because then already know what's a variable, what's a function, what's a loop. Then I don't tell you what's a variable. So, but otherwise there's no prerequisite. So you can learn from the ground up. And why Wolfram language? Because it's the most advanced by a magnitude than all existing industrial languages, including C, C++, Java. That's shit. We already know. So Lisp, Clojure, Scheme Lisp, Common Lisp, no comparison to Wolfram language. You have Julia, you have MATLAB, you have Haskell, you have OCaml, you have F#. No comparison at all. Like, there's a big gap. That's the power of Wolfram language. But of course, there's flaws. That's because Wolfram language is not designed for industrial kind of programming. For example, if you are gonna write an operating system, you don't use Wolfram language. If you're gonna write a networking protocol implementation, TCP/IP, you don't use Wolfram language. If you're gonna write a microprocessor, some kernel, drivers, video mouse drivers, keyboard drivers, you don't use Wolfram language. Okay, but it's the most advanced. If you are doing mathematics, if you are a physicist, if you are an engineer, you have to design rocket, for example, Tesla, or design the Tesla, or artificial intelligence, machine learning. You want to explore all the possibilities. One single line of Wolfram language is equal to 100 lines of Python. Okay, things like that. So Wolfram language, okay, the most powerful, especially if, of course, it is known for doing mathematics, calculus, linear algebra, integration, derivatives. But that's well known. But I'm not doing it. I'm not using it. I do use it for math, but I'm not. But my tutorial is mostly not for that. Okay, it's for just like a Python or Java. Okay, string, regular expression, number, arithmetics, you know, true false boolean. These, you know. So that's my tutorial. So if you like it, donate to me. Okay, so let's begin. Let's start to begin the development code. Let's just code it quickly. I heard that from Steve, from XR Discord. Steve has done lots of these problems. He told me day 12 is kind of hard or tedious. Okay, so let me try to do it quickly. So you finally reach the hot springs, day 12, okay? You can see steam rising from secluded areas attached to the primary something. As you turn, okay, so let me move this here so you can see. So as you turn to enter, the researcher stops you. Wait, I thought you were looking for something, something. Oh, sorry, something, something. You look in the direction the researcher is something pointing, something, something, idiotic. Verbosity. You know, I've seen advanced code, people finish the problem in 10 seconds. before I can read one paragraph, they already finished in 10 seconds or 20 something. You know, if you search YouTube, you'll find some of those people. You know, those are so-called speed coders. Okay, there's a speed coding competition, but it's not a useful. It's not really a valuable skill. You know, in real life or in history, the greatest coders, mathematicians, they are not known. None of them known for, like, I can do it fastest speed coding. You know, it's not valuable. Just like speed typing. You know, it's not a valuable thing. Anyway, so there's just one problem. Many of the springs have fallen into despair, disrepair. So they are not actually sure which springs would be safe to use. Okay, worse yet, their condition records of which springs are damaged. Your personal input. Okay, condition records of which springs are damaged. That's your personal input. Are also damaged. Okay, you'll need to help them repair the damaged record. Okay, so this starting of the problem. In this giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it is operational by a dot or damaged by a pound sign. Okay, this is, you know, so here's the input. That's what advanced code like to do. So a dot is operational. A pound sign is damaged. Okay. So this is a part of the condition records that is itself damaged. For some springs, it is simply unknown, question mark, okay, whether the spring is operational or damaged, okay? So I guess here is the toy personal input. Let's just copy it now. Okay, we want to try to do this quickly, okay? Yeah. So code. Toy input. Okay, so you got a operational is dot, damaged is pound sign, and unknown is question mark. Now I don't see a question mark here, but anyway. So however, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each continuous group of damaged springs is listed in the order those groups appear in the row. For a given row, the size of each continuous group of damaged springs is listed in the order those groups appear in the row. What does that mean? This list always counts for every damaged spring, and each number is the entire size of its continuous group. Oh, okay, I think so. That is, the groups are always separated by at least one operational spring. Okay, so pound would always be 4, never 2. Okay, So contiguous something. So condition records with no unknown spring conditional conditions might look like this. So this is one example input. So pound, pound, and 3 pounds, so that's 113. Then you got 1 pound, and 3 of of their grouping. Here is 1316. Okay, checks out. However, the condition records are partially damaged. Some of the springs conditions are actually unknown, for example. So okay, so you got this. So 113 is still there, but you just don't know what's the question marks. Okay, so second row 113. Okay, so second row 113. 113. Okay, third row 1316. Oh, okay, so you got like this kind of thing. 1316. Okay, I kind of got the idea. Equipped with this information, this is your job. It is your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. So in each row, on the right side, they give a list of numbers. On the left side, you have this question mark and dot and pound sign. Basically, I think you need to figure out what is this question mark, pound sign, dot configuration by removing those question marks. So for each question mark, you want to replace it by a dot or a pound sign, I think. Okay. So in the first line, question mark 31. Okay, so let's hide so I can show you. So there is exactly one way separate groups of 113 broken springs. Okay, in that order, 113. Okay, can appear in that row. The first 3 unknown springs must be broken. The first 3 unknown springs must be broken, then operational, then broken. Okay, pound, dot, pound. Okay, making the whole row pound, dot, pound, dot, pound, pound, pound. Okay, let's double check. Yeah, so given 113 and given this string, there's only one way to replace the question mark, so such that it fits this this description. Okay, that's a condition. So let's start to think about this problem. So given a line, you split it into 2 parts. The right part is the numbers, the left part is a bunch of dot or question mark or pound sign. And basically for each question mark, you want to replace it by either a dot or a pound sign. And the criteria is that so that in the end, if you split this string by a dot, then the count of the pound sign will be these numbers, the sequence of numbers you get. Okay, so that's kind of the algorithm. So given this string, you want to replace all question marks by a dot or pound sign, such that in the end, if you split the string by dot, then you count the group of pound signs. They should be this sequence of numbers. Okay, so that seems to be so it continues to explain. So let's see the explanation. The second line is more interesting. So here, question mark that could be total of 4 different arrangements. Okay. 1, 2, 3. What could be a total of 4 different arrangements? The last question mark must always be broken to satisfy the final continuous group of 3 broken groups. The string. Yeah, whatever. and each question mark must hide exactly one of the two broken strings. Okay, neither question mark could be both broken strings, or they would form a single contiguous group of two. Neither of the question mark could be both broken strings. Okay, broken means a dot. Okay, so yeah, if that were true, the numbers afterward would be 2, 3 instead. Yeah. Since each question mark can be either pound sign, dot, pound sign, there are 4 possible arrangement of the strings. Okay, so basically what it's saying is that the last sentence is saying that there is no, sometimes there may not be a unique solution. Okay, on which question mark you replace with. The solution may not be unique. Okay, now the last line is actually consistent with 10 different arrangements. Okay, because the first number is 3, so what is the last one? Okay, 3, 2, 1. Okay, all question mark. So you have lots of possibilities. Whatever. Okay, so it's saying that all these are solutions to this line. Okay, yeah, so you have many possible, let's say 3, 2, 1. Yeah, so there are many possibilities. Okay, got it. In this example, the number of possible arrangements for each row is, oh, you want to know the possible arrangements, you idiot. Okay, so basically you want to count the possible solutions. Okay, so the first line is 1, the second line is 4 possible solutions, the third one is 1, then 1, 4, 10. Okay, adding all of these possible arrangements count together produces a total of 21 arrangements. For each row, count all of the different arrangements of operational and broken strings that meet the given criteria. What is the sum of those counts? Okay, I got the problem. Let's get my personal input, copy it, and a new file, save it, xx, today's date, AOC 12-1. Let's just say temp file. So this is my file, 1,000 lines. Okay, let's scan it quickly. Okay, yeah, so you see, so the first problem, for each line you want to split them by a space. Is that right? Yes. Now I don't remember the problem says that, maybe because maybe I skipped. But anyway, so you split it by a space, so you get 2 parts, the string part and the number sequence part. Okay, then you just start to find the possible solutions. Okay, so very simple. Okay, Wolfram Language got a lot of functions that do combinatorics, so maybe it's just one single line to solve the gist of the problem. In fact, the whole problem is just one single line. Okay, no more than 120 characters, I'll tell you. So this is the input, so let's make it, so we got the input there. So this solution for this toy problem, close that, is what is this, 21. Okay, let's copy that. Solution for toy problem is, okay, let's just okay, what, text. Okay, actually code. Okay, there we have it. Okay, so let's start Wolfram Language and begin to code. Okay, we got I'm using Wolfram mod, for example, table x129, run it. It takes a while to start up the Wolfram. So there is a result, 1, 2, 3, 4. Okay, so okay, let me show you. So there is a code, Wolfram mod. You can get it free. Open it. Here's the source code, about 3,000 lines, but most of it is the Wolfram language keywords. Wolfram language by default, when you open the box, there are 7,000 functions built in. You don't have to load libraries. You don't have to load any library. Unlike typical programming languages, if you want to use regular expression, you need to load, regex. If you want to manipulate files, you have to load the system I/O or something. Okay, nothing like that. 7,000 functions all built in, and function is all you do. Okay, just functions, because it's a functional programming language. Okay, so here is my website for Wolfram mod. So it allows you to code Wolfram language in Emacs. Okay, so open that file, copy the file path, close. Okay, and put this back, and let's put the link. Okay, Wolfram mod, there it is. Okay, so now let's start Wolfram language. Also, let's start the notepad, the notebook format. Oh, where's my drink? Let me get my drink. Okay, we already spent something like 20 minutes. Cheers. This is orange juice. Start table X5. Let's just say 5 of them. Shift enter to run it. Okay. Now let me magnify this and put this up here. Okay, so that is our today's, so we start to code it. Okay. Okay, so hold on a second. So I need the inputs. I need the toy input. Okay, here's the toy input. Input equals to a string. There it is. So let's pass the input. Okay, string split input. Let's try to code this quickly. If you do that, then by default it's split by white space, so including the new line and also includes the space, which is not what which actually we can use that. Yeah, let's just do that. What is this? X input string or list of strings is expected. What? String split. String or list of strings expected at position 1. So yeah, that's, oh yeah, so I need to eval the whole buffer, not just a single line. Eval the whole buffer. There it is. So once you do that, so all you have to do is partition. Now, so basically here we got a list of things. So it's a string, sequence of numbers, string, sequence of numbers. The sequence of numbers is also a string. Okay, so let me show you this partition. Partition, we'll just group them into let's say let's say 2. Okay, I want to code this quickly, so let's not worry about all the. So let me just show you the easiest way, so I can also, so you guys also understand what I'm doing. So okay, so result. So partition, you want to group them by 2. Okay. Then let's just say, let me just do this quickly. Actually, if I do that, you don't know what I'm doing. So equals to transpose, okay, transpose X result by just transpose. Okay, so once you transpose, you got should you transpose? No. Let's see. So partition. So here the result is a list. Each element is again a list, and the first part is the string. The second part is a sequence numbers in string form. Okay. Then you want to turn this string into actual numbers. So, for example, turn this 321 as a string into actual numbers. You can do split again. Okay, I'm gonna code quickly. Okay, so map. Let's just do map function and write it in a way so you guys understand. So the second, so x is the input. You map to each element in the list, and you want the second part. Okay, so that's the second part, and you want split string, not spline knots. Okay, it's some fancy mathematics knot theory. So you want string split. Okay, you want to string split this thing by a comma. Okay, then you want to turn it into a number. Okay, actually this is inefficient, but let's press on to expression. So to expression will turn. So let's see. So here you got the list. Each element is a single number in string form. Okay, then you so you map. So you map to string to expression, which turns string to number to each of these list element. Okay, so you can see, I don't know if you guys find it understandable. So we don't care about the so what do you want to map this to? So you want to map to x result, which is the result above this. Okay, so I think that we can show the result. Okay, so print. Okay, so if we run the whole thing, it'll run. Okay, let's show it. Okay, so we got why is it saying print? Oh yeah, we on what? Oh yeah, capital. Okay, so let's run again. So there it is. So the result, let me show you. So the result is like that. Okay, we got a and here, what is this part? So let's see, what exactly is that? You see the second part, the second element is a list, but right now I'm not sure it's a list or not. So let's try to run this again. Let's see. Oh yeah, it shows null because good afternoon. Hello Dongwang, and hello D1 6 pounder. Hello LC. So a question about your Wolfram language setup, if I may. Let's see what let's magnify this so I can see. In Emacs, are you calling into Wolfram script presumably using your own mod? Yes, and or the embedded Wolfram language engine. I'm calling Wolfram script, okay? Now, when you Wolfram script and Wolfram engine is free. When you download Wolfram engine, it comes with Wolfram script. Wolfram script is like Bash. It basically is a shell-like interface to Wolfram language, to the Wolfram engine. Okay, so for example, did I just close it? Okay, let me show you. Okay, quickly. So for example, here is shell. Where do I put it? Let's say, okay, so Wolfram script. Okay, we don't want that. Let's start Wolfram script. Let's say 3 plus 4, enter. 7. So this is Wolfram script. When you download Wolfram engine free, it comes with it. Shell interface to the Wolfram language. Okay, so it doesn't show graphics or it doesn't show nice mathematical typesetting like x squared power roots. It doesn't show that. It shows in an ASCII way. But anyway, so I have lots of videos. If you watch my YouTube, there's lots of videos demonstrating Wolfram script. Okay, so anyway, Wolfram engine, Wolfram script you can download for free. But if you buy, like me, actually Wolfram Wolfram Research, they sponsor me. So they, because I've been coding Wolfram language since 1993. Because anyway, so if you have the Wolfram Mathematica or whatever Mathematica or Wolfram desktop product, then the Wolfram engine is called Wolfram kernel. Okay, so basically Wolfram language, you have a front end which is usually the notebook or the Wolfram kernel or Wolfram engine, which is what actually does the whole compiling and computation. So whenever I type something here or in a notebook, it sends the input to the Wolfram engine. The Wolfram engine spit out output. Then the front end, the notebook or the Wolfram script, prints the result. Okay, so your question is about, do I call the Wolfram script or do I call the that's called Wolfram kernel? I call Wolfram script. Okay, now basically they are like exactly the same thing, but I mean the technical difference, what's the difference between the Wolfram kernel and the Wolfram engine you download it free, exactly, I'm not too clear, but it's not important. Okay, and it's not, they are basically exactly the same. So it's not like, oh, if you download free, some feature are disabled. There's nothing like that. Okay, let's get back to this. Okay, so let's see the result. Let's get the first item, then the second item. Okay, let's just run it. You have to activate, because I need to quit the Wolfram script, otherwise it doesn't allow me to run it twice, because. So anyway, running it again. Embedded engine via the dynamic module. Oh, you mean so Wolfram language, they communicate, the front end and kernel, they communicate via a protocol which was called math talk, but now they call it something, let's say Wolfram, it was called math talk. Okay, not walk talk. I believe it was called math talk, and no, it was called but anyway, the front end, the engine and the front end, whatever it is, they communicate via a protocol. So I guess your question is, am I using that protocol? No, but I would like to, because then you are always connected, just like the Wolfram notebook. You don't. But for my Emacs, every time I run a code, it starts the Wolfram engine. I mean the Wolfram script. Then the Wolfram script talk to the Wolfram kernel, the engine. Okay, so it's a bit less efficient, but it works for now. But yeah, so but I have to implement that Wolfram protocol. So well, since I'm talking about this, why don't I show you what is that? I'll just search for Wolfram protocol. Okay, it's called something. Yeah, there it is. Now it's called Wolfram Symbolic Transfer Protocol. Okay, that's how the front end and the back end, how they talk. Okay, and I'm not using that in my XR Wolfram mod for Emacs, but it would be better to use that. But I have to look into. So they have language support for C, C++, for Rust, for Java, for .NET, and other languages. So I haven't looked into yet. So anyway, but in my Wolfram language mod I'm just calling it like a shell command. So it's it's much simpler. Anyway, so let's get back to this. So let's run it and see what's the result. Yeah, no. So because well, if you run this in Wolfram language, it would be much easier. So let's run it. So you can see the result is that now what is so shift percentage sign means last output. So %6 means the output number 6. So I want to see what is that. So is that a string? Oh, so that's a string. So this two expression, this part is incorrect. Function, you map this function. So you map this function to the result, and so first of all you take, okay, so you map the function. Okay, so you split the string. Yeah, okay, so let's say x2, then you forgot to assign the result. That's why. We forgot to assign the result here. Okay, let's assign it. That's why. So the result 3 equals to that. Okay, now result 3 evaluated. Yeah, okay, print evaluated 1. Okay, so 1 is not right. So the first one, and let's just print the result 3. Okay. Okay, so the result 3 is incorrect. Yeah, so yeah, I kind of know. Yeah, so you need return a list, and the first part is what is this? Emacs shell? No. The first part is the first part, then the second part is this. Okay. Okay, so I don't know if you okay, so you got, this will work. Let's just run it. Yeah, so you see, this is what I mean. So this is the desired output, okay? Like that. So, okay, let's copy the whole thing, go to the Wolfram language and paste it there. And we don't need print, because whenever you run in some kind of notebook or interactive form, you don't need print, just like Python or Shell or any other language. So there we go. There, here is a desired output. Okay, so we got a list. Each element is a list of two things, and the first thing is a string, and the second thing is a sequence of numbers. Okay. Yeah, so we wasted a lot of time, like 30 minutes on this. Forgot to name a variable. I mean, assign it. So now we have to start to think about how to solve the problem. About algorithms. So let's see the algorithm. So you got a string. You got a string. You got a sequence number. So the question is, you need to fill out the question mark. So actually, this is not the input. The input is with the question mark. Okay, so yeah, so the input is actually with the question mark. Okay, go back to, so let's fix this here as well. So there. Show in browser, here's today's code. Okay, here's the sample input, and here's our code. Okay. So let's go back to code. Make a backup. Okay, so now, so algorithm. So what you gonna do with this? You want to replace the question mark. Okay, so, okay, so we have to run this again because that's the wrong input. Shift enter. Now it's better. Okay, so there. So now, okay, now we need to think. A bit tedious. So given a string, so wow, how are you gonna solve this? Oh God, this is a bit tedious. So so you can start to do like backtracking algorithm, or there's so you can do backtracking, meaning that you just start to replace each question mark by a dot. Okay, so you find the first question mark, you replace it by a dot. Well, okay, so you find all question marks, then each question mark can be either a dot or a pound sign. Okay, so you just systematically try all possibilities. So for example, the first line, you got 3 question marks. So it can be dot, 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 pound sign, dot, pound sign, or pound sign, pound sign, pound sign, or dot, pound sign, dot. So you generate a list of all the combinatorial possibilities. Then you just try each one. So once you got a possibility, you fill the question mark out. Then you split the string by a dot to see if you have that 113 group. Okay, this is fairly inefficient because you know, for example, the 113, it's not possible to have for all question mark to be ... So if you're gonna try that, you're wasting your time. It's inefficient. But this is a systematic approach. In fact, the question is asking for the count of all possibilities. So you do need to actually know all the possible solutions. Okay, that's interesting. So you do actually need to know all the possible solutions, and because you want a count of it. Yeah, so the problem is not just find one solution. You do need to so you need to find all the possible solutions. So what is the gist? Like what is like some kind of core of the problem that you can just attack there and get the solution instead of trying dealing with the strings and is there some kind of gist? Okay, so these things, this needs thinking. So you need to know actually just a count of them. So finding all possible solutions for filling out the question mark is actually not essential. You see, here's a kind of a twist. I don't know how important this is. The essential thing is merely to know the count of all possible solutions. So I don't know if it's possible you even skipped. You can skip finding all the actual possible solutions, but all you need to know is how many possible solutions are there. Okay, so this gets into more like you have to think about it. It's not just this is a problem. This is anathema to the C++, Java idiots, because they cannot just start to code and trial and error. So anyway, is it possible to know how many total possible solutions without actually trying out, finding all the actual possible solutions? You have to think. Okay, God, it's gonna be another hour. I don't know. I don't know. So you want to find the groupings. So grouping is the key here. 113. So what you can do is, first of all, you take the string and split by the dots. Okay. Then you get algorithm exploration. Take the string and split by dots. Okay, then what you get is a grouping number. Okay, for example, this first line, if you split by dots, you get two groups. Then you see the solution requires three groups. Okay, so let's say G. Okay, you check the grouping count of okay, we need some jargons. What's the jargon they use? The sequence of numbers. What is it called? Continuous group of damaged springs. So is there a name? We need a name to describe these sequence numbers for the sake of discussing the problem. Otherwise it's starting to get very confusing. But I don't recall there's any particular name they are using. Okay, so there's a possible arrangements. Okay, let's describe some description. For each line, there are two parts. One, the string. Okay, let's use a proper name. Let's say string mask. Okay, that string mask is the left side of this thing. Okay, 2, okay, on the left side is string mask, on the right side is, how shall we call it, grouping sequence, sequence count, sequence group number, sequence of numbers, grouping sequence, grouping count, let's just say. Grouping counts, grouping list, something, grouping number list. Okay, grouping numbers. Okay, now maybe that's a better name. So you got the string mask and grouping numbers. Okay, then algorithm. So you got string mask, then grouping number. Okay, so take the string and split by dots. Then what you get is split by dots, count the length of the list. Then what? So the length of the list. Let's say G. Okay, that's a grouping number. Okay, that's a tentative grouping number. Okay, so you split this string mask by sequence of dots, then count the length of the least result. You get a tentative grouping number. Let's say G. Okay, then you compare the length of grouping numbers is, let's say n. Well, that should be G. Okay. Yeah, that should be G. Then let's change this to n. N2. Okay. What? let's say TG, tentative grouping number. Okay, so that makes sense. So count the length of this tentative grouping number. It's a tentative grouping number. Okay, now compare. So you compare the TG with that n. If it's equal, oh God. Now compare TG with G. If equal, if greater, if lesser, what happens? Okay, so if equal, that means you don't need to change the length. So that means, oh God. We are going nowhere. So, but if it's greater, is it possible for it to be greater? No. So is it possible for the left-hand side to be greater, the count, total number of them? No. If lesser, then sum of the question mark means sum of the question mark needs to be split. Okay, so something like that. Okay, lesser, greater. Okay, so most likely it's lesser. So, but if it's equal, no need to change length. Oh God, this live stream doesn't seem going well because too much thinking of this truly require a lot of thinking. Okay, so well. So for example, let's say this line. This line, the left-hand side is just 1 because you split by a dot. There's no dot, so you just get 1. And on the right side, the grouping number is 3 because you got 3 of them, 3 groups. So this is less than 3. That means sum of this question mark. Oh, so their difference. So on the right side is 3, left side is 1. Their difference is 2. That means there are 2 places on the left-hand side you need to split, like insertion point, breaking point. Okay. And tg minus tg diff equals to, okay, and diff is the number of places you need to split. You need to replace by dot in question mark. Okay, it's how can this is the heart. This OBS problem. How can we phrase this precisely? So when the difference, let's say the difference is 2, then that means two of the question marks needs to be replaced by a dot. Is that? No, not necessarily, because you have the issue when the question mark is at the beginning. So what we do know is that you need to split this string further by 2 times by okay, so if the diff is the number of places you need to replace question mark by dot. Okay, and they cannot be consecutive. So you replace question mark by dot, but the next one must be not as neighbors. Okay. Okay, so let's move on. So what if they are equal? So if they are equal, then no need to split further. Okay, if it's greater, greater is actually possible. If it's greater, then oh god, if it's a greater, then some of the consecutive question mark needs or be replaced by dots. Oh shit. Okay, so so far what we have this analysis, but this is not an algorithm yet. So I mean, so the question is how many possible solutions, right? So this is not a solution yet. So suppose if lesser, then so anyone else is watching, I think, I'm kind of getting Oh, 9 people. Okay, so I think I think you just have to sit and do something else, because this problem I cannot keep talking, and trying to solve it. I just need to think like for 5 minutes, because I keep talking and writing about it. It's gonna be 3 hours. So let me just think about it. So you're just gonna stare at my screen, okay? Because otherwise we can't finish. So you need to find all the possible solutions. So, and what we have is you need to find all possible solutions. Okay, but the way we are doing it is first analyzing what kind of split. And maybe this approach is wrong, but okay. So if you go with this approach, then you have the 3 cases. So if it's lesser, that means some of the question mark string sequence needs to be split. Okay, so you need to split by this count. Okay. Yeah, but once you do that, also, first question is you don't know where to split. Okay, you don't know where. So how do you capture this split thing? What is the phrase to describe? Split just means, the essence here is that basically you want to replace a question mark by a dot. That's what it basically means. But however, if you want to split it at 2 positions, then the 2 dots cannot be consecutive, because if the 2 dots are consecutive, you only got 1 split. So another way to say is that you want to split them sequentially n times, the diff number of times. Okay, suppose that then. But there's another question, where do you split it? That's another kind of not simple question. For example, you got this bunch of question mark. There's a question, where do you split it? There's only certain place. You cannot simply, for example, replace the, well, you can replace the first one, but it doesn't make sense if you replace the last one in this case. So how do you capture that? Well, it basically means if you have a pound sign sequence before it, then you can split. Okay, if you have a pound sign, if you do not have a pound sign sequence before it, then it doesn't, then any splitting in the first question mark does not work. Okay, this is too. Okay, now maybe split by dot is not the right answer. Maybe you want to split by, well, actually you do want to split by dot, because ultimately dot is what determines the separation. Okay, so once you, you split by dot, then so our approach, yeah, so presume we use this approach, but then what's the next step? You got a bunch of question marks. You don't really know where to split. Okay, that's the next step. Because in order to know where to split exactly, You have to look into this sequence of numbers. Very, very annoying. Okay, remember, you just need to know the total solutions, the total possible solutions. Let's rethink overall. So total possible solutions, you got a string mask, you got a string mask, you got grouping numbers, you got string mask, you got grouping numbers, and dot means the separator. So, and your problem is to fill in the question mark by either a dot or a pound sign. And so the first step is is it proper? Should you split the string mask by the dot? Is that something you should do? Yes, because this step is absolutely essential. Doesn't matter what you do. I think so. So you split by the dots, then you get some kind of grouping. For example, here we got 1, 2, 3, 3 groups. So these 3 groups correspond to the grouping numbers. I mean the count of grouping number, G, so length of grouping numbers. So when they are same, okay, so actually the easy way, the simplest case is that when they are equal. So when they are equal, you don't need to split further. So all you have to do is this is the simplest case. So all you have to do is for each group that contains a question mark. Oh, okay. So you got 3 groups and you got 3 numbers. So each group has a given number, how many pound sign there is. Okay. So okay. So for example, the first group, there's 1 pound sign. You got 2 question marks. So there are 2 possibilities. So it's about position. So you got 2 spots, and you need 1 pound sign. So there are 2 possibilities. Okay. In the second spot, same thing. You got 1 pound sign. You got 2 spots. So you got another 2 possibilities. The third group, question mark, pound sign, pound sign. Oh, then you need to count the number of pound sign. Then then you got another equal or greater than or less than case. In this case, 2 pound sign, but number is 3, so you got 1 possibility. So the total possibility here is just 2 times 2 times 1 is 4. So line 2, the possibility is 4. Is that right? Yeah. Okay. So far, I think our kind of algorithm approach is still pretty good. Because did we waste in anything that's not necessary? I don't think so. Split is necessary, split by the dot. Okay, so you split by the dot, then you got the grouping number for the string mask. You compare that grouping number to the total. If they are the same, then it's just the possibility for the solution is just the product of each possibility of filling out the pound sign. Okay, just the product. Now that's the case when they are equal. Okay. Now what about the equal and greater? I mean lesser and greater. So if it's lesser, save it, close it, reopen. Okay, so what if it's lesser? Then you need more splitting to do. Okay, so you need to do more split. But the question, so how many times you need to split? That is G minus TG. Okay, this count minus this grouping count on the left hand side. So let's suppose that's 2. You need to split 2 more times. Okay, so do we have a case? 1, 2, 3. 1, 2, 3. Okay, we have a case here. This is just 1. Okay, this is 1, and this is 3. Okay, so that means you need to split 2 more times, right? But here comes the question: how many possible ways to do that so that each position of split is still a correct solution at the end? So we actually need to dive into about when you want to split this, where can you split it? I mean, like, where is what is the algorithm to precisely describe the conditions and restrictions? Where can you split it? In other words, we want to find the possible ways to split this string such that after you split, you can still fill out the pound sign correctly. If after you split, you cannot fill out the pound sign according to the number given, then that split possibility does not count. Okay, so this is complex. Okay, so you want to figure out the possibility. Okay, let's look at another way. So you got given 3, 2, 1, 3, 2, 1. Yeah, it's hard to separate them into 2 issues because you have to fill out with the pound sign. Maybe our approach is incorrect. So, but anyway, so the lesser case, how many possibilities to split? You can split by, so split just means replace a question mark by a dot. So can you replace this by a dot, the first one? No, that doesn't work because on the edge it doesn't work. You still get one group. So basically, if it's on the edge, it doesn't work. Now what if it's on the edge adjacent to a pound sign? I don't know, I'm just playing with this. So what if it's adjacent to the pound sign? If you split there, that works. If you split here, that may or may not work depending on so you have to consider the whole. You can't just think about where to split. Okay, so that's not the right approach. Okay, so that's a lesser case. What about the greater case? Sum of the consecutive question mark needs to be replaced by dot. Okay, so if this count is greater than the right hand side, do we have an example like that? No, actually we do not have an example like that. 1 2 3 3 1 2 3 3 1 3. So you got 2 3 3 3 1 4 3 3 3 3 1 3. There is no case in the toy input such that the string mask it can be split more than that. Yeah, but you see, but the problem does not preclude that possibility, because when you go to the input, let's say this our input, now is there a possible case where the left hand side has more numbers than the right hand side? Very possible. 3. So basically you want to count consecutive dots. So for the left hand side, greater than the right hand side numbers means you gotta have a lot separate dots on the left hand side. Okay, do we see a lot of separate dots? No. So we got 1 2 3 4. Yeah, so it's always less than the right hand side. But though still it's possibility though. So alternatively, there it is. You see the tricky fuck, the advent of code. You see this line 55. On the left hand side, you got 3 groups. On the right hand side, 2. So the left hand side is greater than the right hand side. Do we have, let's go back to, yeah. Yep, so that's one example. The left hand side is greater than the right hand side. Okay, in that case, you need to reduce one of these groups, meaning that reduce all question marks in the group to all dots. Just replace them all by dot. Yeah, so okay, got it. So anyway, so our approach here, we run into some fairly complexities that we don't know a solution yet. The equal case is pretty simple. If the left hand side is greater than right hand side, it's pretty simple. But if the equal case is pretty simple. If the left hand side is lesser, then it's fairly complex. We don't know how to resolve it yet. But if it's greater, that's also relatively simple, because we just replace any group of all question marks in it by a dot. Basically eliminate that group. And we just have to do that. But then the question is, which group can you eliminate? You can't just, okay, God. You see, you can't just eliminate, you see here in this example we got 3 groups. In this case, we can eliminate any group that will work. Okay, but that may not always be the case. There are some cases where there are only certain group you can eliminate, so that the pound sign you can actually fill in and work. Yeah, that is true. For example, in this example, you can eliminate the first batch of question mark. However, if this batch of question mark is only 1 question mark, then this batch of question mark must be the one to eliminate. Otherwise, you cannot eliminate the second or third, because that does not create a solution. Okay. So this thing, so this, in this case, exactly which group we can eliminate depends on the grouping numbers. Yes, fuck. Yeah, but how exactly does it depend? We need the algorithm, so this is also not resolved yet. Okay, so this, our approach so far doesn't seem getting us far. Now let's just think about like the standard normal approach of trying to find all solutions. Okay, you can try, so like we said before, just find all possibilities of the question mark or pound sign, find all their possibilities, then fill them out, each one of them, then check if it works out. If it doesn't, it doesn't count. If it does, it counts as solution. Then just total the solution. In other words, we find all possible solutions by brute force. Okay, by fucking brute force. Now, if you do that, the major problem is when you have a lot of questions. Okay, so if you have, let's say if you have 5 questions, so each question mark is 2 possibilities. So how many possibilities you get? That's 5 raised to the, 2 raised to the 5th power. Okay, so, and that increases quickly. So 2 to the 8th power is 256, that's small, but it's exponential. Okay, that's basically 2 to the nth power. So quickly you become exponential. Now again, you have to check advanced code. They don't have many question marks. So far actually we can actually brute force this. So for each possibility, you just check all possible solutions. Check if it works out. So in this case, there are 10 question marks. That's 2 to the 10th power. That's not too big. That's 512. That's only 512. So fuck the AOC. Because if you are really careful thinker, mathematician, you waste your time. While the brainless diddlers, they work out. They but if you see, their puzzle input doesn't have, for example, I want to see if you have one single line like that, okay, let's just say 2, okay, then all the idiotic, no thinker, no brainers, they stuck on that. It'll take 10 hours to run their program. But the advanced code, fuckhead. Yeah, well, he's not a bad guy, but his problem, this problem, this kind of problem is bad because it punishes those who actually provide 100% correct and efficient answer. If you do that, like me, I tend to be that way. Okay, I'm slow, but I provide 100% correct and efficient answer. You get punished because there's no input, that deal with, the case you are thinking. It doesn't say that case doesn't happen. This is the case with the advanced code. So anyway, let's put let's just say that, okay? yeah, if you get one of these, then the possible solutions is kind of huge. You know, how many 51. So, you know, 51 XOR Emac is mod exponential. What is the name of the exponential function? exp, I think, 228. Okay, let's run it. Real number exponent. What the fuck? Oh, that's natural exponent. Okay, maybe it's always very annoying. Yeah, fuck. You know, you see, this is a common problem among programming languages about the naming of the power function or exponential or the natural, like the natural number e raised to something. So this is actually doing e raised to 8. Okay, that is computing e raised to 8. Okay, and what we want is actually this one. Okay, there it is. You see, you know, 256. So what if you get 10? That's still small. Okay, 10 is 124. Okay, but okay, let's copy that. Let's just put it here for the sake of fun, because you know I'm kind of stuck, so I'm starting to, you know, do the easy thing of just rant and shit. So anyway, so how many, for if we have a case like that, how many characters? 51 characters. Okay, let's see. 51, that's still within normal range, because you know, not many characters. But what is the result? Okay, so here is the result. Okay, stupid Emacs. Okay, so basically you have to try this many times for each, you know, you have to try this many times to verify the solution matches the number given on the right hand side, right? So how many times is that? Yeah, this can easily, I mean, you can still finish in a few minutes, I suppose. So that's what is number? This so here is kilo, mega, giga, petra. Wait, kilo. Wait, so something kilo, mega, giga, petra. 2. Okay, petra, then exa, 2 exa times. If you take 1 second, less than second, so yeah, you know, I don't know, I'm not sure how long that is, but anyway. Okay, so something like that. 51 question mark. Okay, yeah, so you got, okay, so but what are we gonna do then? I mean, should we finish? Yeah, we certainly need to finish, because I'm sure other people finished in 1 hour. A lot of people. I mean, yeah, a lot, the, you know, the fast coders. So if I don't finish this problem, it's not so good. You know, it doesn't look good for my YouTube. So okay, so we analyzed so far. We got this. Yeah, but so far we don't have an algorithm yet. Yeah, so we are thinking of just try, basically. Okay, so I mean, let's write it out. Did we write out yet? So simply brute force replace all possible replacement of question mark by dot, and check if it works. Okay, this is a brute force way. Let's think about, if we do brute force, how easy it be, how easy would it be? Of course, brute force, then you run into, this problem. Then you run into this case. But anyway, but you'll still finish in a few minutes, I suppose, something. But so if we do brute force, which I believe is vast majority of solutions, because that way is the least brain required. Okay, so if we do the brute force, then how easy is that? I mean, can we quickly start to code it? Brute force. So brute force is that so for example, here is 113. You still need to know, you still need to like split first, then okay, so for example, let's say this, if you do brute force, I'm sitting on this chair for too long. I think I need a break. So can you see, this is like ergonomic chair. This is my kneeling chair. Yeah, actually I need to walk and prevent ass rot. You see, usually every day I sit on this chair for a few hours, then I switch to that one. You don't want to sit on one chair all day, because I sit in front of the computer like 10 hours a day. So, and typically every 2 hours I walk around. So now let's sit on this chair, but actually I need a break. Okay, so if you do brute force, you still have the split problem, because you need to, first of all, okay, but let's forget about splitting. Let's just real brute force. Simply just replace. Okay, how do you do it though? So you got question marks, and a bunch of numbers. If you brute force, so what do you need to do? You need to get the grouping right. Okay, so the most brainless brute force is simply, get the number of question marks and find all possible filling of the question mark by either a dot or by a pound. So if you have here 1, 2, 3, 4, 5 question mark, yeah, so it's 2 raised to 5th power, which is small, 128 or 2, 5th power. Yeah, that's not much. 128 or 62 or something. Yeah, 32, 64. Yeah, 64. So you have 64 possibilities. Then for each for each you split the string by dot. Then you count each group, the number of pound sign in each group. Then you check if that matches that. If so, then that's one possible solution. Okay, so you just compute all possible solutions. Okay, this is the brute force way. Now the brute force way, Okay, replace string question mark. Well, the question is it very easy to code? If it is, if we can code this brute force way in 1 minute, then wow, then who cares about, it takes how much time it runs, we solve the problem. But the brute force way, you need to find all possible. Yeah, the brute force way is not too hard, but still, so you got 1, 2, 3, 4, 5 question mark. So basically you got, n spots. Each spot can be possible of two things, 1 or 0, let's say. Then you just get all possible, binary sequence. Then you take that sequence, then you take that string, then you just replace each question mark by, if it's 1, it's pound sign. If it's 0, it's dot, right? So the brute force way, first of all, you count the number of question marks. Okay. The most brute force way is to count number of question marks in the string mask. Then say it's n. Then you have 2 raised to n ways. Find all the possible binary sequence. Okay. Then map a function to the string mask to the as a list. Okay. Okay. They map a function to the binary sequence list. Each time replace question by if it's 1, else replace by dot. Okay. Then split the result string by dot, count for each group and see if it matches the grouping number. Okay, this is the brute force way. Fuck the problem. So anyone is still actually paying attention, say hi. Okay, concurrent viewer 6. Maybe you are doing something. Okay, but we are kind of making progress. Okay, so the most brute force way, actually I want to quit because anyway, the most brute force way is this way. Okay, can we do that? Can we code this? How long does it take to code this, the most brute force way? Let's think about. Hey, Wimbo, hello. Oh, someone is watching me still. Thank you. So the brute force. How long does it take to implement this most brute force way? 20 minutes, I think. So you got the string mask. You simply count the number of question marks. Okay, then you generate a sequence, binary sequence of that number of question marks. You got binary 10100101 of length n. Okay, how do you do that? That is very easy in Wolfram language, one single function. Okay, then you just map a function to this binary sequence. For each time you replace this, you replace all the question mark according to whether it's 1 or 0, right? Yeah, so you get a string, you get a new string. Then you just split the string to check, the pound sign grouping matches that, okay? Yeah, so if we do this way, how long does it take? 20 minutes. 20 minutes to code this. Is that what shall we do? I kind of, should we, yeah, it'll take 20 minutes. 20 minutes, maybe 30 minutes actually, because then I go, I explain things in. But, I myself will take 10 minutes, 20 minutes to implement the brute force way. But the brute force way is insulting, because then what am I here for? If you want to watch the brute force way, I think all the solutions out there are the brute force way. Basically, I'm pretty sure 90% of solutions. I mean, advanced code, I think a lot of people does day 1, part 1, or part 2, or day 2, or day 3. But for day 12, it's exponentially rare, okay? So you won't see a lot of people. I don't think you'll see a lot. We can check. Let's just search quickly, see, do we get a lot. Advent of Code 2023, day 12, 9 a.m. Wednesday in Magalia, California. Fucking idiot. Oh, there it is. Hot Springs, YouTube. Shit. Jesus. He solved in 12 minutes. Actually, it would be interesting to check. So there is Advent of Code, day 12 solutions. Day 12, part 2. Okay. Oh, okay. This guy are persistent. Advent of Code 2023, day 12, Hot Spring in C#. How long does this take? I don't know. This one, Rust. This one, they did it. So let's see how long did it take them. So this one is 1 hour. Okay. This one is 42 minutes. Okay, reasonable. This one is 33 minutes. Oh, fantastic. Yeah, but actually some of them are smart, If they are all doing brute force, then it's not really interesting, because 30 minutes for brute force way, that's reasonable. But it's, it's real interesting. Oh shit, fuck. I talked all this time, sorry about that. Oh yeah, so I was looking at, other people, how long do they take? So, oh fuck, so anyway, so this guy is taking 1 hour in C#. This guy is taking 42 minutes in Rust. This guy is taking 33 minutes. What language is he using? Language actually matters. Wait. So what language? Coding, programming, advanced code, 600 views. What language? It doesn't say. This guy. Let's see. Oh. Dev part 1, dev calc looks like Python. Okay, Python, the most mainstream. 33 seconds. Okay, so these people, now if they solve this problem by brute force, 30 minutes, I think that's normal. I mean, it's normal, it's not too impressive. Okay, but if they solved it by very efficient, like dive into the heart of the problem, then that's more interesting. Okay, so for me, God, I'm thinking what to do. So I don't want to do it brute force, because but if we go back to my analysis, we partition it first. You see, the thing here is that you don't really need the solution. You actually just need to know how many possible solutions there are. So if we go back to this original analysis exploration, this may lead to that answer. Yeah, I think so. You don't actually find a solution. Okay, maybe I should continue this, but if we continue this way, I don't know how long it'll take. One more hour. So you don't actually find a solution, but you just find all the possible solutions. So we get the two parts, the mask string and the grouping numbers. We split the string mask by dot to see how many group we get. Then we compare if it's equal to the grouping numbers or less or greater. So if it's equal, then the possible solution, number of solutions, is very easy. You just, we talked about this before. You just, if it's equal, you just find for each group, you count the possible ways to do it, which is you count the number of question marks by the pound sign required for that group. Well, minus the existing number of pound signs. So you got the difference. So basically you got a number of pound signs. So number of question marks and number of pound signs, how many possible ways to fill that? Then that's the total possible ways for one group. You do that for the second, then you multiply all of them together. Okay, so you don't even actually obtain any solution. You just directly answer what the problem wants. Okay, but that's the simplest case if the grouping number is equal. Now if it's lesser, I'm pretty sure there are people on YouTube who solve this way within an hour. Okay, I'm pretty sure. And there's always a lot of smart people out there. Anyway, so if it's lesser, then some of the question mark string sequence needs to be split. Okay, for example, it's the case here. So yeah, but God, okay, I don't know. Okay, I want to quit. So if we do this way, but we don't have the algorithm yet. We haven't finished. This may, I don't know how long this will take. We don't have the algorithm. If it's lesser, then some of the question marks sequence needs to be split, then so we know how many times we need to split it. Okay. However, we haven't, however, you cannot simply split it anywhere. There is, these restrictions. So let's think about this. There are these restrictions. So how can you maybe shortcut? So there are these restrictions. 1316. So in this case, the number here is 4 counts. The number on the left is 1. So their difference is 4 minus 1, 3. So that means this string mask needs to be split 3 more times. Okay. Now, here's the question. How do we know which are the possible split? Is it possible? I mean, first of all, we know we cannot split on the edges. Okay. Because when you do that, if you replace those question marks by dot, it doesn't do anything. So you can only split by replacing a question mark to a dot, only if that question mark happens not on the edge of the current group. Okay, that's one thing. Is not on the edge of the group. That's one of the condition. Okay, so you look, then okay, that's one of the condition. Then if it's inside, because for example, can you split this one? Yes. But can you split this one and not those two? Not whatever coming from? No. Because the first group must have one pound sign. So if your first split is here, then you don't get the possible solution. Okay. So given a string mask, they must be split 3 times. In other words, they must be 3 separators, 3 dots in between. Okay, so instead of looking at it this way, kind of sequential, you have to look at. So what is that you need to have 3 dots instead of saying split. You just need 3 dots inside this mask. Okay, not on the edges, but 3 dots inside. But also, but not just anywhere. So you cannot have the first dot here, because then that does not solve the problem. So okay, so in order to determine where you can place the dot is to judge on the pound sign. Okay, so here is the case. You need to split by question mark. No, yes or no. Well, anyway, but I mean, so this question mark, 3 of them needs to become a dot. The problem is you don't know where. So if you look at the pound sign, the first one needs to be 1. So another approach is you just look at the pound sign. Oh, that's more direct, because this sequence of numbers, grouping numbers, directly tell you you know, how the pound sign, I mean, they specify about the pound sign. So the first one must be 1, then there must be a group. Okay. So they specify the pound sign. The grouping of the pound sign. Okay. So basically, this problem is that you got a string. Okay. Then you have these groupings. Okay. The groupings can split. So think of a kind of like a cable or a wire. Okay. Then you have kind of abacus on it, you know, like children's toy. You can push it around. Okay, let's just random talk and digress. Yeah, kind of like that. You know, so you got a toy. Yeah, fuck. You know, you got a toy like that. Fuck, I don't want this. I just want this picture. Yeah, you got a toy like that. So think of each row of this thing, of the string mask. What's that? You know, so you got these beads you can push around, form groups. So the real, you know, the question is just about this grouping and question mark. Okay, so I mean, and they specify. So what is another approach? You know, our approach here is getting too hard. Is there another approach? You know, so you are given a string of certain length. The length is always fixed, okay? And you just want these possible pound signs with a dot. Oh, okay, so there's another approach. Okay, so in this approach, kind of new approach, fuck the problem. New approach, ignore the input. Simply take the fixed string. Simply, for each line, consider the length of the fixed string on the left. Let's say string mask. Okay, so that's the length. For example, I mean, this one is 7, right? Then not ignore. I mean, simply for each line, consider length of the string mask. Let's say n. Then the sequence of grouping numbers. Okay. Let's say 7. Okay, so this is 7 and 3. Yeah. Okay. Let's say something like that. Okay. So this is 7, and this is 1, 1, 3, and total length is 3. Okay, so for 7, so consider binary string, binary number of 7 digits. Okay, then you just compute possible grouping of 1. in this binary number, okay? Then ones, okay? Then it needs to be 113. Okay, so okay, so you actually, if you do this approach, this is not so good then, because you want to consider all the possible combinations of consecutive ones in a binary number of 7 digits. But then you need to and then consider such groupings of 113 basically. Oh yeah, okay. But then minus, but you see your binary string still needs to fit into this given mask, because the pound sign is like 1, okay? The dot is like 0. So your binary string cannot, even though you find all the possible such binary digits with grouping 113. So let's say you have 1,000. But you have to consider the problem given is that the rightmost 3 digits is 1. So you have to minus the So you have to minus the given mask, okay? Okay, that's not good. Too much, So if we do that, so is this approach any easier at all? Oh, okay. So why don't we minus the mask first? Yeah, so we only the part we don't know is just the question mark part. I mean, back to our problem. So just the question mark part. So given this specifically placed question mark, so yeah, again, we are thinking, we want to think about this problem from the beginning again. So given like a binary sequence, certain slot we don't know, we want to fill it so that so we want to know the total possibilities, okay? We just want to know the total possibilities of doing it. But the constraint is that we are given this mask, okay? The mask on the left hand side, okay? So I got nothing to do now. So let me just do this. So this makes it more easier to see somewhat. So the left hand side is the mask string. How do you do it though? So we are not, is there a way, is there like a much significantly simpler way? Because this problem is a combinatorial problem, okay? If we capture the gist, then we can solve directly this combinatorial problem. we can of course do the brute force. Yeah, but that's the most boring solution. I think that's what people do, I'm guessing. But I mean, maybe they are smart. But there was way too many edge cases I didn't think through ahead of time. At first it seems day 12 will be relatively easy. Okay, so problem, solution, part 1, part 2. Oh, they did both of them. Fuck. And ChatGPT. Wow. I doubt ChatGPT can solve the problem, correctly. They can just give like suggestions. So this guy using Rust, okay, I live stream this on Twitch. I can occasionally weekday morning. Okay, my Rust solutions. Okay, my question is, did you solve it brute force? Whole afternoon after work for this problem and couldn't solve it. I thought I can use some combinatoric math to solve it, but it was the case for me. Then I found your video, your dedication to the problem, as well as the sound you make. You solve it. Just give me more energy to revisit. Okay, thanks, Uncle. Okay, now I'm the granddad then. This was impressive. I brute force part 1, then worked on part 2 for 2 hours before I had to start work. Then in the evening I did another 2 hours before setting aside again. Finally, my third session, I managed a similar but less elegantly written solution. Okay, so it seems this guy did not use brute force. If it's brute force, it's not really interesting, because if it's brute force, then the interesting part is how do you use the language. Okay, the programming language. I simulate. Okay, so his name is Uncle Scientist. This guy, Uncle Scientist. That's why he's uncle. I simulate being smart by taking 4 times longer to think about things than normal people. Oh, okay, like me. I spent 2 days doodling on paper trying to reason my way through a solution before the second half of this video started. Okay, so they didn't solve it on the spot. Okay, they had some preparations, I guess. Spent 2 days doodling on paper trying to reason my way through a solution before the second half of this video. Yeah. So this is not real time. So what about this guy? Twitch using Python. Did you brute force? How did you do today? You are finally posting about it. Amazing. Great explanation. Thank you. You can see the code to see if they are brute force right away. Yeah, this low resolution. Go index plus index left else m index pound index go index. Looks like line in input, calculate line, print total. Okay, pretty short program. Line split, then cache go index left index return 1 return 0 index length number. Define go. Okay, total 0 m index dot else if equals to 0 equals to. That looks like brute force. Oh, okay, so he's still coding it. So that's his personal input, I guess.
I misunderstood this altogether. Okay, fine. And I could have done part two. That's your story was enough. And even then.
Okay, any comments? Okay, maybe I stop. So let me think about this again. Now it's 2 hours and 20 minutes. Okay, so you got this binary number, a mask. You got a mask. Your problem is filling out the question mark. Your problem is filling out the question mark by either a pound sign or by a dot. So, it's much more familiar if we just think of this as a binary digit of certain length. The pound sign is just 1. The dot is just 0. Okay, the question mark is the part you have to decide whether it's 1 or 0. Okay, then so grouping given, so first of all, given this grouping, certainly there's a combinatorial possibility. So first of all, if you know the total length of the grouping numbers, then you already know what is the total possibilities. Okay, once you know how many grouping numbers are there, you know how many total possibilities. Okay, then but then you see, it's not just about grouping total number of groupings, but each number in a group matters. Okay, so in other words, yeah, so actually, yeah, so like I said, there are two parts. Given a binary number of certain digits, and given this grouping number 321, you already know, let's see, you already know how many possibilities are there. But so given this binary sequence, so the problem is actually you really do want to split by dot first. Then like our analysis here, then you do want to split. Then you focus on each sequence of the question mark, because then you do not know if you need to. Yeah, actually our problem analysis here is good. You have 3 cases, equal to, lesser, or greater. Then I'm not sure what to do. I need to walk. So you need to, so you have the situations. Yeah, so this is a good way to go, first step. Then you got equal, lesser, and greater cases. So the equal case is very simple. The lesser case is more complicated, because it's lesser group, you need to do more split. So for example, like this one we talked about, you need 3 more dots. Oh, Oh, okay. It's either dot or a pound sign. So if this, you need 3 more dots here, then the rest is gonna be pound sign. Yeah, obviously. But but the question is, where do you put the 3 dots? How do you know? What is the algorithm? What is a efficient algorithm to place 3 dots? You know that it cannot be on the edge of the group. So that's one condition. What are the other conditions? So we need to continue to think about this. So you cannot be on the edge, and it cannot be 2 consecutive. You cannot put 2 dots consecutive because otherwise there's no split. So okay, so consider this case for, let's say, in this case we can only split once. It's not possible to split it twice. That's right, that's correct. So if you want to split once, it cannot be on the edges, so you only have like 2 possibilities. Now what about more question? Okay, for what about this one? So this one, let's say it's required to split it twice, 2 more times, to obtain total grouping of 3 parts. Okay, so we know already it cannot be on the edges, so that leaves that. Then okay, so we need to split, and we know it cannot be consecutive, so this, the first one here, this can be a dot, then the dot just can be anywhere. Okay, but then the dot can be this one beginning with this character. So but what is the exact condition? So you got 2 dots, you got a bunch of spots, split. So what are the possible ways to split? Okay, I think I know. Okay. I think I started to know. Okay. So once I know this, yeah, I kind of started to know. So I mean, first of all, it cannot be on the side. Yeah, so we got, we just basically got a bunch of question marks. And well, but that's not the total condition. Also another condition, I mean, it's not just about split, because once you split, this, you need to fit this. Okay, I think I give up. This problem, it needs more thinking. It would be, if we did the brute force, it'll work, but we didn't do that. It's already 2 or 3 hours. So if we continue to force this mathematical way, more thinking is required. You just need to think about this problem. It's some kind of binary number mask problem. And this problem, it is my guess, is well known. I mean, maybe obscure, but this problem is somewhat common. I mean, not common, but I mean, it must have came up before. In engineering, in computer chips design, because this is, and it's kind of a math problem. It's basically just about masking binary numbers, an efficient way to have a sequence of binary digits such that the groups of digit ones forms this pattern, and you just and also given this mask, you need to a very combinatorial problem. Now I get more closer to understand the math aspect. A very clear combinatorial problem. You got a sequence of binary digits, a fixed number of digits, and you got a fixed positions of ones, and you want to find the total possible ways of such binary sequence such that this pound sign are already 1, so definitely this is the approach, definitely, but you just need to think more about it. And look at the cases. For example, this one, 111. So you see, so first of all, about the possibilities, one of the most important thing is how many digits are there, how many groupings are there. That's the most important, because once you know that, you kind of eliminated a lot of possibilities in all possible binary sequences. So that's one important thing. But the other important thing is that the existing ones, that also eliminate a lot of possibilities. Okay. So to approach this problem, you can approach it either from pure, I mean we are approaching, in this combinatory or binary sequence way, which is mathematical analysis. Okay. So forget about actual forget about the actual coding, trial and error and brute force. Okay. Because this brute force way is never gonna fly, because this brute force way, if you have, let's say binary digits of 100 digits, all these brute force way, they fail. They fail. You want a formula. Okay, so the problem, the solution, the most efficient and correct solution to this problem is one single formula. Okay, it's not about manipulating strings. It's one single formula. This formula tells you how many possibilities given a fixed number of string, a binary digit, a fixed number of binary digits, and these grouping numbers. And okay, that's one thing. But and also, where specifically, so these slots are already 1. Okay, then the question is just combinatorics. Okay. So I need to solve it. I need to think about this some more. It's sequence. So you can't just magically come out with a formula. It's not a pure formula because you already have certain positions field. So the formula needs to have some kind of encoding for these field positions. Now, the exact position of these ones occur, it does not, it actually is flexible, okay? It's actually flexible. For example, let's say this one. There is, what I'm saying is that given this line, we know there's a solution, right? Let's say n possibilities. Now, what I'm saying is that given this number, there are more than, there may be different fixed position of the pound sign that also have n possibilities, something like that. So, in other words, this input is not unique, not necessarily unique. So for each of these lines, there's another number that is the total possibilities, okay? So we got three things. One is this fixed mask, string mask. The other thing is this grouping number. And the third thing is total possibilities, okay? So what I'm saying is that if the grouping number and total possibilities are fixed, this string mask is not unique neither, okay? So again, this is a combinatorial problem. So I'm just making progress in talking about it. And but we need to actually pursue how do you solve it. Okay, so I'm gonna stop. Okay, so I'm gonna stop. We failed, I'm not gonna continue. But I will continue and finish this problem and do a live stream, probably tomorrow, okay? So I will think about it so that maybe tomorrow or maybe after tomorrow I'll start a live stream and I'll start to code instead of, thinking. I'll just tell you guys how I think about this problem. Pure combinatorial solution, okay? There would not be string manipulation. There would be just, But now, so let's look at what other people, is this guy also doing the pure combinatorial solution? No. You look at his code, you got this which for arrangements, size, iteration, count, restart, length, matching on regular expression, I guess. This is while loop, which self, no, this guy is not doing, it's basically brute force, okay? Let's see the next guy. This guy, advent of code in C#, okay? Let's see what he got.
Hello everybody and welcome.
Arrangement, pattern length, group count, pattern index, pattern length equals to smaller than that, pattern length plus 1, okay? That looks like another brute force. For pattern length 1, for else if pattern length count equals to 1, arrangement, brute force. So three quick web search, it seems like they are all brute force. Okay. Now Reddit, let's see, so You see this guy. I tried to use combinatorial to solve today's puzzle, but failed. My brain burned out. In the end, I just used brute force. Yeah. Okay, I don't care about that. Olivia Code 2023, Day 12. Share your solution. Berkeley Edu. Oh, Berkeley Edu. They got smart people. You need JavaScript on. Why is it not opening? Okay, this is a thread to discuss day. Remember, it is very important not to write any public spoilers. Oh, shit. Community software Swift Forum, Event of Code 2023, Swift Forum, Hi Swift community. Okay, so they are coding in Swift language. Okay, so here's some code. Location, group point, so part number, append, part number, what is this? Initial table, grid count, grid, is this actually? Okay, that's not, I don't think that's not. Day 2, puzzle 2, okay, something. Okay, so here's the thing, guys. I'm gonna shut down today, not having done the problem. But so you guys look around and comment, okay? Hello, EU. Morning from Ukraine. Hello. So I kind of failed doing today's problem after 3 hours. So this is so let me wrap up. Okay, let me explain what's going on in the today's talk show. This is Advent of Code 2023, Day 12. Okay, so I read the problem in the past about 3 hours, I think 2.5 hours or something. 2, 3, 4, yeah, close to 3 hours. I analyzed the problem and didn't really code anything, except that's just passing it. Okay, so we didn't code, but I went over trying to find ways to solve this problem in a efficient way. But so one approach is simply brute force, and eventually I search the web. It seems all these people are just doing brute force. Now brute force, of course, solves the problem. It would be great. I didn't do. It will take me, I think, 20 minutes or 30 minutes to actually write the code to brute force it. But brute force is not an interesting solution, because if you do brute force, well, you get to learn how to code in that language. In this case, Wolfram Language or Python or C# or Rust, but you just learn the programming language. But however, from our analysis, this problem is basically a combinatorial problem about binary numbers. Binary, kind of like a mask, a binary sequence, given a fixed binary number, fixed number of digits, and certain digits are 1 already, and given that their grouping count of ones, consecutive counts of ones, you want to find how many possible how many possibilities for such binary sequence. Okay, that's when you want to fill out the question mark. Each one is a binary digit. You want to replace it by 1 or 0, so that this consecutive ones count grouping numbers is satisfied. Okay, so this is a combinatorial problem. So ideally, the solution is simply a mathematical formula. Okay, you don't do loop, if, check, like you don't do that. Ideally, the solution is a combinatorial, a math formula, like 2 raised to the power something plus something. And if you do that, each of the binary sequence, they need to be encoded somehow, which position is 1, which position is not. It actually can be just a string, just like that. So anyway, the solution should be a very simple mathematical formula. And as far as my guess, I guess this problem is already known. It's a known problem, okay? Maybe obscure, but it's a known problem in binary sequence. Okay, so that is where we are today. I didn't finish it, so I think next time, maybe tomorrow, but maybe not. Maybe I'll do a video live stream on something else, on Emacs or on politics or something, or on keyboards. But we'll come back next time. I come back to this problem. I will have already thought out and give you guys the solution, how to code it. Okay, so that is the situation for today. Thank you guys for watching. Too bad no solutions today. Okay, that's it. Bye guys.